So nowadays everyone talks about transformers, and may it be AI models like ChatGPT or Claude or Gemini or using Llama. But very few people ask a simple question: why do transformers even exist? Why didn't RNNs or LSTM solve everything? And why did the entire AI world change after 2017? So, in today's video, we are going to understand how NLP evolved before transformers, and we are going to run a small experiment in Google Colab to see why attention was needed and the entire concept behind the transformers, while the entire explanation about transformers will be in the next video. In today's video, we will see why RNNs and LSTMs didn't work and how attention was needed, and because of which the theory of transformers and everything happened. So let's start. And the first topic would be, what is AI, ML, DL, and all these terms. So AI stands for artificial intelligence, which means making machines behave intelligently, whereas machine learning means learning patterns from the data. So we have different data sets having huge number of data points, and by learning those patterns, though the process is called as machine learning. And whereas deep learning means using neural networks with many layers to perform different tasks. So for language problems, so the language related problems which were being faced in AI models, so there was a one big terminology or a one big field called as NLP, which is natural language processing, and all those language related problems come in NLP. So we'll understand why the language part is hard for AI models. So the problem is that language is collection of words, and word depends on other words, and while the meaning of different words and the sentences depends on the context. And this is the problem because of which the RNNs, LSTMs didn't work. So before transformers, NLP used methods like bag of words, RNNs, and LSTMs. So let's understand the problem of each one in brief. So bag of word problem was, it ignores the word order. So if we use bag of word algorithm, then it ignores the word order. So for example, you have two different sentences like dog bites man and man bites dog. Then using bag of words, as there are those are same words but very different meanings, but the bag of words they look almost the same. So for using the bag of words, these two different sentences carry similar, or you can say same meaning. So that was a problem with bag of words. While in RNNs and LSTMs, RNN read just one word at a time. So the text which is read by RNNs are one word at a time. So this caused problems like the training was slow, then long sentences were hard, important words were forgotten by the model, and even LSTM struggled when context became too long. So researchers ask a big question: can we look at all words at the same time instead of like one by one word? So this was the problem which was solved by the concept of attention. So instead of reading sequentially, attention asks that which word are more important for understanding this word. So every word looks for all other words. So this attention concept solves the long range dependency issue, or allows parallel computation, allows understanding. And this idea was introduced in the famous paper of Attention is All You Need, which was published in 2017. And this is where the transformers were born and the concept of transformers came into picture. And at its core, a transformer is a stack of attention layers, and no recurrence, no convolution. And it usually has encoder which understands input and decoders that generates the output. But instead of jumping into the full architecture now, we'll keep the detailed architecture part in the next video, and let's prove why attention is better with a simple experiment using Google Colab. So now let's switch to Google Colab, and it's not a complex project, it's a quite simple experiment, you can say, to see why attention is better and why attention is important to solve such NLP related problems and the transformer concepts, everything. So first I am importing some basic libraries. So the basic libraries I have imported are NumPy and Pandas. And the next cell says that we are declaring two simple sentences, which are first dog bites man and second man bites dog. So these are same words, the sentences have same words, but the meaning is opposite, you can see. and humans can understand this quite easily. But let's see how machine handles this. So as we have discussed some points related to bag of words, so I'm in this cell I'm using bag of words method, and this method counts words, ignores orders, and ignores the position. So from this you can see the output. Both sentences look almost identical. So for this model, these two sentences, dog bites man and man bites dog, means almost the same thing, and this is where the meaning gets lost. And in the cell 4, now instead of counting words, let's keep the sentence as sequence of tokens. And from this you can see that this feels already closer to how language works. And now in the next cell I have used word embedding, so I have randomly generated some word embeddings for this, and now each word is converted into vector of numbers. So in real models, these embeddings are learned from used datasets. So based on used datasets, these word embeddings are being generated. And here I'm using random vectors just for intuition purpose. And the important idea is, now words are not just words are now numbers, and numbers are being compared to each other. So the simple attention function, this is a very simple simplified attention function in the sixth cell, in the next cell which I have written. So without worrying about much of the math, conceptually we can see that one word asks who is important to me. So the concept here in the attention function would be that the one word asks which one word other word is important to me, and other words responds, and the importance score is been calculated based on the embedding value which we have seen in the previous cell. And this information is combined, and this core idea of attention is what we can see in this cell. And now we can see that by applying the attention, we want to see that which word matters the most. And from this output of this cell, we can see that the model does not treat all words equally. Some words get more attention while some get less, and this is what we call is that context. So in this output we can see that the bites word has more importance than the other two, and similarly the other, like the dog and man, have different attention or value which you can see, and this tells us the importance of that word and hence builds the context. And because of this entire concept of attention, we can see how the transformers and the latest AI concepts are being developed. So this was it for this video, and in this video we have learned about bag of words, and the problem with bag of words is that it treats all words equally. And also we have seen that how attention is important and how context is built using that. So from this we can remember this, that transformers didn't win because they were complex, but they won because they solved a real limitation. And using transformers we can understand the context, scale well, process language in parallel, and that's why almost everything today is built on transformers. And three things to remember is, language need context, sequential models don't scale well, and attention allows global understanding. And that's the foundation of GenAI in this video. And in the next video, we'll go deeper into the concepts of transformer, and we will build self-attention from scratch using queries, keys, values. And by the end, you will finally understand what KQV actually means. And see you in the next one. This was it for the video.